This is Peter Mowen demonstrating Embedded Systems Lab 9, Intellectual Property in Vivado HDL. In this lab, we were asked to create a custom IP block that takes a 32-bit unsigned number as an input, counts the number of ones in the first 15 bits, and then displays that number, the number of ones, to the LEDs on the Zybo. So in this video, I will show you the Verilog code that does that, and then show you the C code that feeds the number into the Verilog code, and then show the output on the Zybo.
So this is the block diagram for our project, and here is the LED controller, the custom LED controller IP package. So if I go in here and edit in IP package manager, I had already opened one of these to test, so it's okay to overwrite that. So we're waiting for it to initialize this project, and everything's coming up. I'm not going to change anything, but I just am opening this just to show you guys the Verilog. So if we come down here, open this file up, all of this is just generated by Vivado, and I do not touch it. I just come down here to where it says add user logic, and I create a 4-bit register to hold the temporary LED sum, and also a 4-bit iterator that I called I, and then create another register, this one 32 bits, to hold the contents of slave register 0, and then I open up an always combinational logic block, initialize the LEDs sum, set the temporary slave to the what it was ever in slave register 0, and the value that's in this register is the value that's fed in from SDK. And so now I just enter a for loop and set I to 0, where I goes from 0 to less than 15, and then just increment it. And then if this is a 1, then we just add 1 to temp LEDs, and then we assign that LEDs out. Well, we assign temp LEDs to LEDs out. And LEDs out is a custom output that we added up here for the user added ports. And that was done in a ZyncBook tutorials. I believe it was tutorial like 4. Yeah, and so that's the Verilog side of things. So we can close this project. And this, all of this was wrapped, and we created a bitstream, and this is what gets loaded to the FPGA to control the hardware. So here's our C code that'll get loaded to the Zybo. At the top here we have this LED underscore controller.h header file. This is a header file created by Vivado HLx that gives us functions that lets us interact with our custom LED controller IP block. And here is the sequence that I will be feeding our LED controller. I've listed the number in base 10, its binary representation, and then what I expect to show up on the LEDs. So for example, if I look at the number 1 in base 10, that has a single 1 in binary, so we expect the LEDs to show 0001, indicating that there is 1, 1 in the number 1. If we take a look at the number 15 in base 10, its binary representation has 4 ones in it, so we expect the LEDs to show 0, 1, 0, 0, indicating that there are 4 ones in the number 15. And so on. So this is the pattern we expect to see on the LEDs as it goes through this sequence. So down here in the main section, in the main function, I just got a variable to hold the LED value, the size of our sequence, so I could add more numbers if I felt like it later on. I probably won't. And then a couple of iterators to get into our sequence and just for this time wasting for loop. So we can actually read the LEDs. So in the main while loop, we just go through every element in our sequence. We're going to print that out to the terminal, assign it to the LED values variable, write that LED value variable to our controller using this function that's part of the LED controller header file, and then just wait so that we can actually read it. So if I go ahead and do run as, launch on hardware, and we can see that we see the numbers showing up here in the terminal, and we can see the LEDs on the Zybo. And this is indeed doing the pattern that I expected.